Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2471, minimum number of operations to sort binary tree by level. This is a very good tree based question, and here we will be utilizing the concept of BFS. Let's have a look on the problem statement. In this problem we are given root of a binary tree with unique values, okay? And in one operation you can choose any two nodes at the same level and swap their values. What we have to return is return the minimum number of operations needed to make values at each level sorted in the strictly increasing order. This is level. What is level? The same number of edges from the root. So this is level 0. This is level 1. 4, 3 are at level 1. And this is level 2. 7, 6, 8, 5 are level 2. And this is level 3, 9 and 10. What we have to make is, we have to make this array, we have to make this tree sorted by level. So every level values should be sorted in the increasing order, strictly increasing order. This is level 1. There is only one element, it's already sorted. This is level 2. If we require sorted values, it should be in this form, 3, 4. First one is 1. And what about level 2? Level 2 we have 4 elements, 7, 6, 8, 5. And if I have to sort these values in the sorted form, they will look like this, 5, 6, 7, 8. So this is the sorted form. And for this, these are already sorted. Okay, so what we have to return is minimum number of operations required to make these levels sorted. So if we try to break down the problem, every level, you consider it as a array, okay, and you have to sort that array and find what are the minimum number of operations required to sort that array. So we can break this problem statement something like this. You are given an array and you have to find the minimum number of swaps to sort that array, okay, and you can apply this operation on every level because every level is an array. So for this, first of all, we need to do one thing. We need to capture all these levels. First level, second level, third level, and fourth level. Okay. One thing is you can capture all the levels. Or second thing what I can say is that go level by level. Firstly, process first level and see what are the number of swaps required. Secondly, process second level, then third level, and so on. Okay. It means first of all I am concerned about first level, and then I will do some operation and I will append some value in my answer plus equal to something, and then I will process second level, and then I will go to next level. It means we need to iterate or traverse this tree in the level order fashion. So we definitely have to do the level order traversal, and I hope you understand what is level order traversal. Firstly, we are processing 1, and then in the second level, what are all the elements on the second level? 4, 3. These are from the second level. 7, 6, 8, 5. 7, 6, 8, 5. These are from third level. Usually there are two common ways to traverse a tree. First one is DFS, using recursion. And second one is BFS. BFS is applied using queue. First of all, we just add one element or our root element in the queue, and then that one element is our zeroth level, L0. L0, we will process L0 and add all the children of this element. Let me give you a brief idea. Let's say this is my queue. In my queue, firstly I added 1. Okay. This is my first level, level 0. And then what I will do is I will process every element of that level. Let me change the color. One I have processed, and left child and right child I am adding into the queue. Left child is 4, right child is 3. Okay. Now we are done processing first level or level 0. Now this is going to be my next level. Capture the length, level 1. You have captured the length and process each element and add its children. If you are not able to understand it, just watch any dedicated content on level order traversal, or let me know if any help is required from my side. Okay, we'll do the level order traversal, and after doing the level order traversal, let's say we have captured the level in an array or in a data structure. Now you have the level. Okay, let's say you are having 7, 6, 8, 5. What you are going to do now? You will find minimum number of swaps required to make it sorted in the strictly increasing fashion. All the elements are unique. If you sort it, they will definitely be in the strictly increasing fashion. Okay, and whatever is the minimum number of swap from that level, I'm going to append in my answer plus equal to swap from that particular level. So we are going to apply this operation on every level, and once we are done iterating this tree, we will have our answer. Okay, I hope this is clear to you. Given the array and find the minimum number of swap to sort that array. Let's say somehow we have the utility function that is going to give me the answer of minimum swaps to make it sorted. If we have that utility function, we'll be able to solve this question by using DFS or level order traversal. 5, 6, 7, 8. This is the sorted form, and from this to this we have to capture the minimum number of element. And let's say we are able to find it in some time, t time. So t is the time for our utility function. On this level order traversal, time complexity is order of n. We already know because we visit every single node of the tree only once. So what we are clear so far is we will do the DFS or level order traversal, and we will capture every level data. Okay. Now the sub problem is given array of the integer and find the minimum number of swaps required to sort that array. So given is integer array and return the integer swap required. Let's say this is my example 4, 3, 2, 1. This array is not sorted and we have to sort this array. So for the given level, we require minimum number of swap to make it sorted. Okay, so this is our sub problem that we have to solve. We are going to discuss two approaches, and our first approach is that first of all for every ith index we have two possibilities, that either that is already at the current index, and the second possibility is that is on the wrong index. If that is on a correct index, it means we don't require any swap. If that element is at wrong index, we require one swap. We have to swap somewhere. So let's say this is something like this 4, 3, 2, 1. As we can swap any value of I with I and j. Okay. So let's say when we are planning to swap ith element, we should know the jth value, which is the actual value that should come at this position. Let me show you what I am trying to say. This is the given array. Firstly, let's capture the sorted form. Sorted form of this is 1, 2, 3, 4. And now we are at 4. Let's say my I index at 4, and I want to know which item should be at this location. Which item? The item present in the sorted form. The item present in the sorted form should be at this position. 1 should be at this position. Okay. So we are currently at ith index. And at ith index, we have value equal to 4. And we want to make it replaced with value 1. And 1, what is the index of 1? That we don't know. So we have to find the index of 1 in our levels array. So find the value of this 1 in the level. How do we find that? We can find it in order of n time. We are trying to build the easier approach first. So let's say we are spending order of n time and we find the index of 1. Let's say index of 1 is j. Now we are sure that we have to swap I and j. J is having 1, and when I swap I with j, this I element will be having the actual element. Okay, it means that we can move our pointer I to the forward direction. So I is having 4 value, j index is having 1 value. If I swap I with j, I is going to have 1. So the sorted form after one operation will be 1, 3, 2, 4. And my I index is at 3. It means that this portion is already sorted, and this portion we have to do. We have to do the same thing. Okay. For for 3, what is the element that should be present at this position? Currently I index is 1, and what value should be at this index? Value 2 should be at this index. So we know the index of 1 and we want to know the index j, which will be at this position. So j2 should be at this position, and where index of 2 in the level array that we can find in order of n time, we can iterate over the array again, and we find out that 0, 1, 2. 2 is present at index 2. It means index 1 and index 2 we can swap. So after this swap, it will be like this: 1, 2, 3 and 4. And now we come to the next position. Here I is 3. Element at I is 3. I is also 3 and value at I is also 3. And now what value should be at 3? Just see it from the sorted array. From sorted array I got to know that 3 value should be present at this. And in the problem statement it is given that we have unique elements. It means that item is already present on the right index. If that is already present on the right index, don't do anything. Just move ahead. Same for the j. Same for the I equal to 4. 4 element is here, and from the sorted form we got to know that 4 should be here. So yeah, this 4 is also at the right place, 3 is also at the right place. In short, we require 2 operations. Whenever we are doing a swap, we can increment our counter. 4, 3, 2, 1. So what we did is we iterated over this given level array, and along with this we also maintained a data structure which is sorted form of this level. This sorted form of this level is giving me the element, that it is giving me the element in order of 1 time, that this element should present at this ith index. So let's say I is 0 in the starting. I can know from this array that at index 0 I should have 1, but currently I am having 4. So find out where the 1 is present in this array. So and replace or swap these values. So this is our approach. So currently what we did is, first of all, I did a sorted operation. I have the level and I make the level sorted. To make the level sorted, what is the time required? N log n. Order of n log n to sort this array, sort this level. After that, what we have to do is we are iterating over this I and then finding the value of j. Iterating over this array using I pointer is going to take order of n time. And then when we are iterating to find j, what is j? The actual value that should present at I. That is also order of n. So n log n plus n into n. So in short, the time is going to be order of n square. So order of n square is required to find out the minimum number of swaps required. This order of n square, when I submitted the order of n square approach on this problem, it gave me TLE on one test case. So somehow we have to optimize it further. Ultimately, we know that we have to do the level order traversal, or you can say BFS, and BFS is going to take order of n time. That is fine. Okay, for every level we have to do something, which is finding minimum number of swap required to sort that level. That is currently n square. So somehow we have to optimize this time. And how can we optimize this time? What we were doing is we were finding the correct index. For every I value, we were finding the correct index. For correct index, firstly we capture what value should be present at I. This is order of 1 time. We checked it from the sorted form. And then finding j. Finding j is taking order of n time. Somehow improve this time. Improve the time to find j. Find j. What is j? J is the position of element in the given level. Position of element in the given level. So for 4, 3, 2, 1. Sorted form is 1, 2, 3, 4. I am processing index 4. Index 0, which is having 4. So 4 should be replaced with this one, currently order of 1 time, and this one is present in this array at what index? J index. And how much time to find j? Order of n time. How can we improve it? If somehow we are able to maintain a map of the given array, that this value is present at this index. Let's say I'm having a map. This is the given array and this is the sorted form, and from the given array the map is this. Okay, so what we have to do is we need to replace 4 with some value. Which value? This value. And this value is present at what index? This index from the map. Order of 1 time we are finding, order of 1 time we are finding, and this is third index. So third index and 0th index, just swap it and increment the counter plus plus. Simple. So this is the approach. So first step is sorting of the level. Second step is hashing of level. Just maintain the hash map of level. This hash map is helping us to find the index in the order of 1 time. So this sub problem is looking complex and you might find a very complex solutions outside, but it is very simple, that we are given an array and that just capture the sorted form and maintain a map, and for every index I you have to find j. J is the one which should actually be present at I. This much we have to do. And here what is the time? We are iterating over it and doing every other operation in order of 1 time. So ultimately the time of this approach is order of n, and time for sorting is order of n log n. So ultimately this process is giving me order of n log n time, and this map is our space and array is our space, or you can say order of n space and order of n log n time. Let's have a look on the code. Here in the code what I'm doing is I'm just doing level order traversal. This is the tree given to us, and on this tree I'm doing level order traversal and I'm capturing every level in this data structure. Okay, and on every level I'm doing some kind of operation, and that operation is counting number of swaps required for this array. And what is that operation? Is counting number of minimum swaps required to make that array sorted. And whatever is the minimum number of swaps required to sort that particular level, I'm appending in my answer. So for every level we need to do this count swap 2. Let me call it count swap. Okay, this is the n square time approach. I'm not going to discuss it. So this is a n log n approach where I have firstly maintained a copy of the given level. This is the given level to us, and firstly maintain a sorted copy. This is a sorted copy of this level, and this is the map of actual index in the given level. Level.getI, this is the value and this is the index, and I will be iterating over the given level, and I'm finding that whether that element is at the right position. If that is not the right position, it means that value is not matching in the sorted form. Then what I have to do is find the correct index, like index of the item which should be present at I. So I and j we are finding, and then we have to swap I and j. I is my current element and j, this is the j value that we have discussed. And we also need to make sure that we are updating the values in our map, because that in that given level array is getting updated. So the map should be updated accordingly. Yeah, this much we have to do. And this is our particular our naive level order traversal using queue data structure, putting the first element and then its children. And yeah, after every level, this while loop is for particular level. After every level, performing some operation and appending our result. Yeah, this much we have to do. I'm submitting our sample test cases, submitting the problem. It got submitted successfully. I will be attaching the link of this code in the description below. Please have a look and have a look on the comments. If you are not able to understand, just comment down below. I will be happy to help. Okay, thank you guys. Thanks for watching. Bye bye.